So if we're going to try and do a free body diagram and try and make it accurate, one of the things I want to do is try and make the arrows proportional to the size they're supposed to represent. So if the weight is 200, I'm going to draw an arrow that I'm going to start with that's 200. But the green box's weight is 250. So I need to make this one long enough to demonstrate that the downward force from that weight is bigger than the downward force from the other weight. Right? They're supposed to be proportional. Now, I have to draw an upward force representing the tension. And the tension has to be greater than the size of this arrow, less than the size of that arrow, but has to be the same for both boxes. Because the tension on the left box is the same as the tension on the right box. So when I draw this, I want to draw an arrow for tension that I make the same size over here. So the two tensions appear to be the same length. But I need this one to show an unbalanced force downwards, and I need to show this one an unbalanced force upwards. So if you want all the credit tomorrow, then a point's going to be given for these two arrows being the same size. A point's going to be given for the unbalanced force here being downwards, and a point's going to be given for the unbalanced force here being upwards. That's 3 points probably for your free body diagram. But you won't get any points if you just draw arrows and they're all the same size. Right, except for the fact that the two tensions have to be the same. So I would encourage you to just keep that in mind. Your drawing has to be consistent with what happens. Now, there's a couple of things I saw that were some mistakes here, but for the most part, I think I walked around and corrected many of them. Is this a first law problem or a second law problem? So I have to apply that to both objects. One of them can't accelerate without the other one also accelerating. They're connected together. And like I said at the beginning, we need a unified direction that we call positive. I'm calling this the positive direction. So anything over here that's upwards is positive, and anything over here that's downwards is positive. But I believe it's going to accelerate with one mass going up and one going down. So now, as I write this out, this has to accommodate all the arrows that are in one dimension. So I think we're talking about the y direction for this one, right? Because there's nothing going on in the x direction. So 250 is downwards, I make that positive. Tension is upwards, make that negative. That equals, this m isn't any m, it's talking about this box specifically. So it has to be that box's mass. So that's 25A. Go to the other side, I have to do something similar. So this time up is positive, so T minus 200 equals 20A. Now, when you get to this point, I ask you to find A and T. This is no longer a physics problem. This is something you did in algebra. You have a system of equations. You have to figure out a way to solve for these two variables. You have lots at your disposal. I showed you one method, but you could solve one of these for T and plug it into the other. That could be your method. Some of you are confused by me saying, okay, just put them together and add them. You don't have to do it that way. If you want, do it the way you were taught in your math class. Solve this for T. Then take all of this and put it here for T. It's not better or worse, it's just different. But do whatever you need to do your algebra. If I do it this way, distribute the negative sign. add 20 to both sides and subtract 200 from 250. It's not terrible. Complicated, maybe. Lots of places to make mistakes, but not terrible. And we're not done yet. You have to figure out the acceleration. But, I'm sorry, you have to figure out the tension. You can do that in either place. In fact, for some of you, it might be best if you do it twice. Do it there and do it here. They need to be the same answer, and if they're not, you made a mistake. Because unfortunately for you, on the test tomorrow, you won't be given the answers ahead of time. So if you work this out and you get different answers, you know you made some algebra mistakes, probably. You probably got a sign wrong somewhere, something like that. But, this is t equals 200 plus 20 times 1.1. This is where you get your 222 newtons. All right. I think you need more practice because we're having this quiz tomorrow either way. So let's try another one, shall we? Now, on the last test, I was accused of giving you test questions that were different than the homework. Look, they're all going to be different. Do you realize there's lots of different ways I can make one of these problems? And so you're not going to get a test question that is not going to be perfectly exactly the same as what you guys have been doing, but they should be very similar and they will all follow the same kind of procedure. On the other hand, look, I can give you every permutation of the problems, but you don't want to do 150 homework questions. In fact, some of you just won't. So understand this is another version of that problem. Let's see what you can do with it. All right, let's assume, again, I haven't changed anything. We're not adding anything new, just a slightly different modification. Imagine I take one of your tracks and I put the pulley on both sides of it and I hang two things off either end. Can you find the acceleration of this system? Can you find the tension in the cable? 15 kilograms and 12 kilograms. Just turn them on their side. Again, I'll give you the answers. Tough for how to deal with multiple objects. Yeah, I can't. Because all the stuff from the last test is still going to be on the next test. So, are you capable of... What's that? Sorry, can't do it. Could you do this problem? So easy to discount it out of hand. How do you think this changes the problem? Because this is getting closer to what I think you should be able to do. Now, one of the things that this does is it does make a substantial change in what you have to do. It's not as hard as it looks, but it is different. Let's, for the time being, say that there's no friction. That doesn't change the fact that did the inertia of the system change? Yeah. Those of you who nodded, good job. More mass is having to be moved now than before. Here's the biggest change. This box, the only way it accelerates is if it too is experiencing an unbalanced force. What that means is that there's going to be one tension on the right side and a different tension on the left side. And that's how this problem is going to be different. Try this one. This is getting closer to what we have to do. And trust me, if you didn't like this one, you're definitely not going to like the next one. So I'll put the answers on the board for this one too. So the acceleration for this one can get the acceleration, you can probably get the other parts too. You have to choose a common direction you're going to call positive. I think the system's going to go this way. So that means this direction's positive, this direction's positive, and this direction's positive. Well, 150 minus TL equals 15A. I didn't draw a free body diagram. I think I know there's just two forces acting on it. It's like the last one, right? One downwards and one upwards. Now this one, yeah, there's four forces on it, sure. There's, weight, and there's normal, but those are going to be equal and opposite, right? They're going to net force is zero because it's not accelerating up or down. What I really care about is the fact that there's TL to the left and TR to the right, and TL is probably greater than TR. That's the only way it accelerates to the left. But that's going to give me TR minus TL equals 20A. Now I'm left with the last one, and that's going to be TR upwards minus 120 equals 12A. Yep.
I have a quick question. For TR and TL, why is TL negative? I thought it would be backwards.
Oh, okay, I'm sorry. I think you're right. I think I made a mistake. Thanks for helping me out there. That probably makes more sense since I said to the left will be positive. Now, you can do substitution here, but this is one of those cases where I really think you're better served adding these together. Because if you add them together, do you see that there is a positive TL and a negative TL? And a positive TR and a negative TR. If you do this the way I'm suggesting, these will all cancel out, and you're just going to be left with 150 minus 120 on the left side. That's a lot easier than substitution. But on the right side, you're just going to add all those things together. So 12 plus 15 plus 20 times A. Now you understand the rest of this is what we've already done, right? So this will be 30 on this side. This is going to be 47 on this side. And then you just divide and you get your acceleration. Now, just plugging in numbers isn't interesting. I think we should look at a different example, okay? Because you need to see what's possible, and I think you're going to get this one. There's absolutely no reason why we couldn't have something that looks like this. What's that? So silly. So I think this is within our capabilities. 7 minutes, not a lot of time, but enough time for you to get a try on it. Again, still not adding any friction. Try it, please. Folks, there's only 4 minutes, and you really need to have this experience. I'm not saying this is your quiz tomorrow. I think your quiz is going to be more basic because I got to know where all of you are when you're working without your friends and without your notes. I'm going to choose this as the positive direction for my problem. Now, it doesn't matter which direction I choose. I just have to pick something and stay with it. I think this box is going to be experiencing 2 forces. 50 newtons downwards, tension upwards. This one's the easy one. And I think tension minus 50 equals 5A. No worries on that one? All right, this one's tougher. There are three forces acting on it. We have weight, we have normal, and tension. Now, if you'll recall, you have to choose a coordinate system. I'm going to choose one in which the down the ramp is positive. So I choose a coordinate system. This is my positive x direction. This is my positive y direction. I have to remember that the 30 goes here. It's a lot to remember. But guys, we've done ramp problems so much. Look, you don't have to make this an ordeal every time. There's always going to be a portion of the weight that is into the ramp, and that's always going to be mg cosine theta. There's always going to be a portion of the weight that's down the ramp, and that's always going to be mg sine theta. Go ahead. The tensions have to be the same. Yep. So this T and this T have to be the same. But we've done a lot of these. I need you to start realizing the ramp problems are all the same. Now that I've done that, I only care about this force and this force. Those are the only ones that matter. So mg sine theta is down the ramp. So that's going to be 200 sine 30 minus tension equals 20 times A. Now, there is also normal minus 200 cosine theta equals 0, but does that contribute to the problem at all? No. Now, we have our two things. And I chose sine of 30 because it's a half. So if we add these together, again, do you see the t's cancel out? So 200 sine 30, that's 100. Minus 50 equals 20 plus 5 times A. Now, folks, in your notes, real quick, remind yourself about this stuff. This is not the hard stuff. It's hard because there's so many things. So many things. I mean, this is going to work out to be 2. And going back to figure out the tension, probably there. It's the easiest one. But, all right.